The diagram below is the speed time graph of an object. The object starts from rest and accelerates uniformly for 2 seconds until it reaches a speed of 10 meters per second. It then travels at this speed for 8 seconds and finally decelerates to rest after 5 seconds. Now the first question is find the retardation of the object in the last 5 seconds. B. Find the distance traveled in the first 10 seconds. And C. Find the average speed of the object for the whole journey. So how do you deal with problems regarding the travel graphs? Well, there might be some people out there who might not even know where to start from. So for the sake of such, we're going to go through some key points that might help us understand this particular topic and also help us deal with problems on this topic. So let's deal with some key points. Now, an object may move from point A all the way through to point B. And as it starts to move, its speed is going to increase significantly until the speed becomes constant. That is, the speed is neither increasing nor decreasing. And then it is going to decrease until it comes back to rest again. Now, this particular journey is demonstrated using the speed time graphs. A speed time graph shows how the speed of an object changes with time. So let's say we have this particular graph. So the y-axis is going to give us the speed. This is showing how the speed is changing. And the x-axis is going to tell us how the time is changing in seconds. And here we can have 0, here we can have 5, here we can have 10, here we can have 15. And let's just say that we have 10, and here we can have 20. Now, for any object under normal circumstances, the initial speed should be 0. In other words, before it makes any movement, logically, it must have 0 meters per second as its speed, right? So as it starts to increase its speed, not only is the speed changing, but the time also is changing. So it is going to move like this until it reaches this particular point where the speed becomes constant for a period of time, and then the speed decreases until the object comes back to rest again. So this is showing the journey of an object. Notice that the speed is increasing from 0 all the way up to this particular point, which is 20. So it moves from 0 meters per second to 20 meters per second. Now, that speed is actually also called velocity. And this change of velocity with time is actually what we call the acceleration. The acceleration shows the change of velocity with time, and it is given by this particular formula, the rate of change of velocity with time, which is actually final velocity minus initial velocity over time. So you might be asked a question to say, what is the acceleration of an object during the first 5 seconds? Notice that you have the first 5 seconds here. So from this point to this point, this is the first 5 seconds. So how do you deal with this particular problem? How can you calculate the acceleration of this object during the first 5 seconds? Well, this is the formula that we use. So make sure that you recall that formula. So first of all, we have to find what the final velocity is and what the initial velocity is. Since we know the time here, when you look at the time, it is actually 5, because we are talking about the acceleration of this object during the first 5 seconds. So what is the final velocity in this particular case? Well, this is the maximum velocity. And notice that this is 20. That is the final velocity. So we're going to have 20 meters per second as our final velocity. What about the initial velocity? Notice that this is 0. This is the velocity of an object before the velocity starts to change. So in this case, it is actually 0. So we're going to have 0 meters per second here. And the time in this case is 5 seconds. So you have everything you need to calculate the acceleration. So this is going to be, what is the final velocity? It is 20 meters per second minus the initial velocity is 0 meters per second. And the time in this case is 5 seconds. So this is going to be 20 minus 0 is 20 over 5. So this is 20 meters per second and this is 5 seconds. So in this case, the acceleration is going to be 4 meters per second squared. And so this is our acceleration. Now, this kind of an acceleration, you'll notice that we have a positive value. This is called positive acceleration because this is when the velocity is only increasing. It is not decreasing. So this slope here is actually called positive acceleration. Notice that this is increasing. So this is called positive acceleration. Now, here when you look at this point here, the velocity starts to decrease significantly until it comes to rest at the 15th second. Now, this is also called velocity. Notice that the velocity is decreasing. It is decreasing significantly until it reaches the 15th second. Now, since we are dealing with the rate of change of velocity with time, you realize that this particular change is actually called negative acceleration. While this is positive acceleration, this is negative acceleration. Now, the negative acceleration is also called deceleration, or it is also called retardation. Now, when we are asked to find the deceleration or the retardation, the formula is just the same. It is the same formula for acceleration, which is final velocity minus initial velocity over time. Except that since this is talking about deceleration, we are going to get a negative acceleration. That means that when you're looking at the values like the final velocity and the initial velocity, you're going to realize that for the positive acceleration here, the initial velocity is actually 0. But for the negative acceleration, notice that the initial velocity is actually 20 because it is starting from this particular position. And while the speed or the velocity as 20 is the final velocity during the positive acceleration period, you realize that the final velocity during the deceleration is actually 0. So when you are talking about acceleration and deceleration, all you have to understand is that for the acceleration, you have the initial velocity and the final velocity. When you're dealing with deceleration or retardation, the initial velocity of positive acceleration becomes the final velocity of negative acceleration or deceleration, while the final velocity of positive acceleration becomes the initial velocity of the negative acceleration. So let's say we are being asked to find the retardation or the deceleration of this object in the last 5 seconds. So how do you deal with that? Well, again, in this case, the final velocity is going to be this. So this is 0 meters per second, while the initial velocity is going to be this, which is 20 meters per second. And the time is still going to be 5 because this is from 10 to 15. So this is going to be 5 seconds. So the negative acceleration is going to be, what is the final velocity? Notice that it is 0 meters per second. 0 meters per second minus the initial velocity in this case is 20 meters per second. And the time is still 5 seconds. So this is going to give us the acceleration of negative 20 meters per second over 5. And this is going to be negative 4 meters per second squared. So notice that the acceleration in this case is negative. So this is what we call negative acceleration. Now, you might also be asked to find the distance traveled by the object. Now, the key thing which you have to remember, always remember, is that for the distance, anytime you see the question about finding the distance, you should understand that it is talking about the area under the graph. This is very important. The distance covered by an object is always equal to the area under the graph. So for example, if they ask you to find the distance covered or traveled by an object, so for example, if you are asked to find the distance traveled by an object during the first 5 seconds, then you just have to look at this same shape here. This is the shape showing the distance during the first 5 seconds. So this shape is going to give you the distance. So if you can calculate the area under this graph, the area of this shape, then you can get the distance traveled by an object during the first 5 seconds. So let's just say we want to find this particular distance. The distance traveled or covered by an object during the first 5 seconds. So notice that the shape here is the triangle. So all you have to do is get the formula for the area of the triangle, which is going to be half BH. And so in this case, we are going to get half, and the B is this, the H is here, the height. So the B is from 0 to 5, which is actually 5. So we're going to have 5 here times the height here is from going up to 20. So this is going to be 20. So 2 can go into 20 10 times. And so 5 by 10 is 50. And so 50 meters is the distance traveled by an object during the first 5 seconds. Now you might also find the area of this figure. If they say we're trying to find the distance covered by an object for 5 seconds from second 5 to second 10. So in that case, you just have to look at the shape again. This is a rectangle. So the formula for the area of the rectangle is actually LB. And in this case, it is going to be, this is 5 to 10 is 5 times, then when you're looking at this, this is 20. So again, this is going to be 100 meters. So this is the distance traveled by an object from second 5 to second 10. And you can do the same for this. If you are trying to find the distance traveled, the total distance traveled, all you have to do is calculate the entire area of the figure given, and you're going to get the total distance traveled. Now, you might also be asked to find the average speed. Now, speed is equal to the distance traveled over the time taken. So this is the standard formula for speed. When I'm talking about the average speed in this case, it is given by the total distance traveled over the total time taken. So always remember this particular formula. Whenever you're asked to find the average speed, this is the formula that you use. So in this case, we can calculate the average speed by looking at the total distance traveled. This gave us 50 meters, and this is 100 meters. This also should be 50 meters. So in this case, the total distance is 50 plus 100 plus 50, which is 200 meters. And when you look at the total time taken, this is 15 seconds. And so 15 into 200 is going to give us, this is 13.3 meters per second. And so this is the average speed for the entire journey. Now let's go back and deal with the question that we are having. The diagram below is the speed time graph of an object. The object starts from rest and accelerates uniformly for 2 seconds. So notice that it is moving from rest and it accelerates for 2 seconds here until it reaches a speed of 10 meters per second. And then with this same speed, it travels for 8 seconds from this point to this point. Notice that you have 2 and 10. So it travels at this same speed for 8 seconds until it decelerates to rest after 5 seconds. So from this point to this point, this is deceleration. So it's from 10 to 15. After 5 seconds, it comes back to rest. And so this is the journey of this particular object. So the first question is, find the retardation. And notice that this is retardation. This is negative acceleration. Find the retardation of the object in the last 5 seconds. Let's first erase this. Whenever you're finding the retardation or deceleration, remember that you're talking about acceleration, except that this is negative acceleration. So let's write the formula here. Acceleration is equal to final velocity minus the initial velocity over time. So let's collect the data here. So what is the final velocity of this object? Notice that when you're talking about positive acceleration in this area, you realize that the final velocity is 10 and the initial velocity is 0. But since we are dealing with negative acceleration or retardation, we're dealing with this particular area. So in this case, you notice that the initial velocity is going to be 10, while the final velocity is going to be 0, because this is 0. So we're going to say the final velocity is actually 0 meters per second, whereas the initial velocity is going to be, this is 10, so this is going to be 10 meters per second. And the time is going to be 5 seconds. So with this data, we can go ahead and calculate the retardation. So the final velocity is going to be 0 meters per second minus the initial velocity is going to be 10 meters per second. And the time in this case is going to be 5 seconds. So this is going to be negative 10 meters per second over 5 seconds, which is going to give us negative 2 meters per second squared. And so this is our retardation. What about the second question? Well, for the second question, question B is asking, find the distance traveled in the first 10 seconds. find the distance traveled in the first 10 seconds. So you are talking about these two areas. Notice that the first 10 seconds are from 0 to 10. So this whole shape must be included. And remember that when you're talking about the distance, it is always equal to the area under the graph. So in this case, since we are talking about the distance traveled during the first 10 seconds, then we are only going to consider the two shapes here. There is the triangle and there is a rectangle here. So let's go ahead and find the areas of these two figures. So let's call this A and B. So for A, that is the triangle. So this is going to be half BH. And this is going to be half. The B here is from 0 to 2, which is just 2. And the H is from to 10 here. So here we are going to have 10. And so 2 is going to cancel 2. And so the area is going to be 10 meters squared. And for shape B, notice that this is a rectangle, which is given by LB. So for L, it is from 2 to 10, which is 8, multiplied by from 0 here, this is the resting position, from 0 to 10, this is 10. And so we are going to have 80 meters squared. So the total distance in this case is going to be 10 plus 80, which is actually 90 meters. And so 90 meters is the distance traveled during the first 10 seconds. But what about the last question? The last question is asking about the average speed of an object for the entire journey. Remember that the average speed is always equal to the total distance traveled over the total time taken. So in this case, all you have to do is find the total distance and find the total time. And therefore, we can go ahead and deal with this. Notice that we've calculated the distance of this shape and the distance of this shape. So we can only find the distance of this shape to get the total distance in this case. So what is the distance? So let's first find the distance covered by an object in the last 5 seconds, from 10 to 15. So that is also talking about the area of that particular shape. So let's call this C. So you notice that C is equal to half BH, which is equal to half. Here we have B, which is 5. And then we have H, which is 10, from 0 to 10 here. So we have 10. And so this 2 is going to go into 10 5 times. We are going to get 25 as the area of this particular shape, which means that the total distance is going to be, we found 90 meters plus this 25 meters. So we're going to get 115 meters as the total distance traveled for the entire journey. So we can go ahead and find the total time taken. Notice that we've been given the total time taken here. All you have to do is just look at the time here. This is the total time taken. So the total time taken is actually 15. So the total distance is 115 meters and the total time taken is 15 meters. So we can go ahead and plug in into the formula to find the average speed. So in this case, the total distance traveled is actually 115 meters and the total time taken is actually 15 seconds. So what is 115 over 15? So this is going to give us 7.67 meters per second. And so this is the average speed for the entire journey. And this is how we deal with this particular problem. The diagram shows the speed time graph of a car during a period of t seconds. So look at the diagram and see what you can identify. The first question that we are having is find the acceleration of the car during the first 8 seconds. So during the first 8 seconds, find the acceleration of this particular car. So the formula again is acceleration is equal to final velocity minus initial velocity over time. So according to the information given, what is the final velocity of this particular movement? Well, notice that the final velocity here is 9. So we can say 9 meters per second. And what is the initial velocity? Well, under normal circumstances, the initial velocity is actually 0. And that is the case in this particular diagram. So 0 meters per second. And notice that it is talking about the acceleration during the first 8 seconds. So that is the time that we have. So the time is 8 seconds. So we can go ahead and find the acceleration in this particular case. So the final velocity in this case is 9 meters per second, and the initial velocity is 0 meters per second, and the time is 8 seconds. So this is going to be 9 meters per second over 8 seconds, which is 1.125 meters per second squared. And so this is our final answer for this particular problem. Now, the next question is, how can you find the distance covered during the first 14 seconds? So this is the distance covered during the first 14 seconds. So this is B, the distance during the first 14 seconds. So how can you deal with that? Well, notice that during the first 14 seconds, we have this particular area. And remember that when you are dealing with the distance covered, you have to find the area under the graph. So if you look at from 0 to 14, notice that we have two shapes again. We have a triangle and we also have a rectangle. So we can just go ahead and name this as area A and this is area B. So we can say area A is a triangle, so this is half BH, which is going to be this is 8 times 9, because half BH, when you look at 9, this is the height. When you look at 8, this is the breadth. So 2 into 8 is actually 4. So what is 9 times 4? Well, 9 times 4 is actually 36. So 36 meters squared is the area of that particular shape. Now for B, you notice that this is a rectangle, so it is LB. So what is the value of this length from 8 to 14? Well, you will see that this is actually 14 minus 8, which is 6. So the length here is going to be 6 times, and then we're going to have the same height, which is 9. So this is going to give us 54 meters squared. So when you add the two, the distance during the first 14 seconds is going to be the distance of area A and the distance of area B, which is 36 plus 54. And so we are going to get 90 meters. And so this is the distance covered by an object during the first 14 seconds. Now, what about the value of t? The second question is about finding the value of t if the average speed of the car is 7 meters per second. So let's look at it. So this is c. The value of t if the average speed is 7 meters per second. So how do you deal with this particular problem? Well, remember that when you're dealing with the average speed, you are talking about the total distance over the total time taken. Notice that we are trying to find the value of t here. And according to the information given, this is the total time taken for the whole journey. And since we have the average speed, which is 7 meters per second, then it will be easy for us to go ahead and find the value of t. Now, since we have 7 meters per second here, notice that we need to find the total distance of this particular figure. We only have the distance for area A and area B. We have to find the distance of this particular area as well, including this one. Now, since we found the area of A and B and not the area of C, let's call this C, we also need to find the distance covered in this particular area, because when we are dealing with the average speed, remember that we are talking about the total distance over the total time taken. We don't have the total distance yet. We have the distance of this area and this area. And so let's try to find the distance of this particular shape so that we can have the total distance to help us calculate the total time, which is t. So this shape here is a trapezium. Now, if you flip it, it is going to look like this. So this is how it is going to look like. And here you are going to have 7, because notice that from here to here, which corresponds with this particular shape, we have 7. And then here we have 9, because this distance corresponds with this distance. So we have 9. Now here we are going to have t, and here we have the 14th second. So this is actually t minus 14. So this is what we have here. And so whenever you are dealing with the area of the trapezium, it is always given by area is equal to half, and we are going to have A plus B times H. So this is the formula for the area of the trapezium, and this is what we are going to use to find the area of this particular shape. So this is going to be area is equal to half. Now A is corresponding with this particular side, and B is corresponding with this particular side. So these two variables are talking about the two parallel lines that are making up that trapezium. So in this case, we are going to have A, which is 9, plus B, which is 7, and the height is here, which is actually t minus 14. So this is going to be area is equal to, this is 16, and 16 by 2 is going to be 8. So this is 8t minus 14. So when we have that as our area and the distance which we have, which is 90, then the total distance is actually 90 plus everything here. So let's go ahead and deal with this problem. Let's first rub this off. So the total distance is going to be equal to 90 plus, and this is 8t. Now we can actually evaluate this. What is 8 multiplied by everything that is in the brackets? So here we are going to get 8 times t, because we have this 8t minus 14. So 8 times t is equal to 8t, and this is minus 8 times 14. Now 8 times 14 is actually 112. So this is the distance for this particular area, and so we can go ahead and add it to this. So we are going to get 8t minus 112. So this is the total distance that we are going to have. Now the total time taken is actually t. This t here is the total time taken. So we have this information. We have the total distance here, and we have the total time, and we also have the average speed, which is 7 meters per second. So we have everything that we need to calculate the value of time. So let's go ahead and deal with this particular problem. So the average speed is going to be equal to total distance over total time. So the average speed is 7 meters per second, and the total distance that we have here is 8t minus 112 plus 90 over time. So this is 7 meters per second is equal to 8t. Negative 112 plus 90 is going to give us negative 22 over t. So all we have to do here is to find the value of t, to solve for t. So this is going to be t multiplied by 7. So this is 7t, which is equal to, we're going to have everything here, which is 8t minus 22. So we can collect the like terms. We can collect the like terms here. So this 8t is going to go to the other side, and it's going to change the sign. So we're going to have 7t minus 8t is equal to negative 22. So this is going to be 7t minus 8t is negative t, which is equal to negative 22. So we are not solving for the value of negative t, rather the value of t. So we're going to divide this by negative 1 to cancel that negative sign, and t is going to be equal to 22 seconds. And so this is our final answer.